Let's take another look at our flying squirrel data, the data on body weights in these flying squirrels. And I want to do two things. Number one, I want to construct some 95% confidence intervals for those data. And I'd also like to perform a significance test where we try to determine is there a difference between the body weights of males and females. So in order to do that, what we're going to do is go ahead and type in some of the same commands that we used last time. So first of all, we're going to clear the memory. So rm list equals ls paren. Okay, so we've cleared the memory. Now what we're going to do is type in nfs WTS, that's going to be the name of our data set. The arrow, the less than symbol, I guess, followed by read.csv, and then file.choose, and then paren, and then I want comma header, because my data file does have a header. Header equals T. Okay, so I didn't just then have to hit enter. And now a dialog box is opened up behind the screen. So let's open that up. I now have to show R where that is, and it's in this directory right here. There it is. So it's in under my folder for experimental design. Under box plots, and there it is, nfs data.csv. So that's my comma separated value data. And I'm just going to hit open like that. And you can see that over here now in the global environment, there's the data set. It has 16 observations with 3 variables. So let's go back over here now and just type in nfs WTS. And what that should do is show us the data set, and there it is. Okay, so there are all of our observations. So we now know that we have the data successfully imported into R's brain. Now, to do what we did last time, we're just going to type attach. And we want to attach this data set, so nfs WTS. And the data set is now attached in R's brain. So let's do box plot. And grams. If you'll recall, grams was the variable of interest in this data set. And there over on the right-hand side, you see our box plot. Ta-da-ta-da, there it is. Okay. Now let's make this just a little bit different. Let's type in box plot grams. And I now want to use divided by sex or organized by sex. So tilde sex. So it's now going to give me box plots by sex. And scroll back down here to where I want to be. I've got 3 computer monitors all going at the same time. Grams by sex. Let's go ahead and just hit that. So there we go. Now you can see that I have the side-by-side box plots, and that's labeled one for males and one for females. Now all I'm going to do is t.test. So I'm going to perform a t-test on grams. Okay, and right away it gives me the result here. Notice I did not separate by sex this time, so this is giving me a one-sided, or rather a one-sample t-test. And this t-test is essentially asking the question, are the weights of these flying squirrels equal to 0? I could have specified what the theoretical mu would have been. I didn't do that, so it assumes that it's 0. I don't particularly care. I mean, this is sort of a trivial little exercise. What is interesting, however, if you look at these data, is the fact that it gives me the 95% confidence interval. So I know across all of these flying squirrels, right, I'm 95% certain that the true average body weight is somewhere between 166.6108 grams and 209.0642 grams. So my average is 187.9375, and I know that I'm 95% correct if I say it's going to be somewhere between 166 and 209. All right, let's make it just a little bit more interesting. And what I want to do now is do the t-test again, so t-test. And now what I'm going to do is specify grams. And this time I'm going to use the tilde sex. So now I'm suddenly doing a two-sample t-test. And now what it does is it's testing the hypothesis that the means for males is equal to the means for females. And it's constructing the 95% confidence interval for the difference between those means. So I'm asking the question, is the body weight for the females minus the body weight for the males, is that value equal to 0, yes or no? Okay. And if you look at the 95% confidence interval, what you discover is that the difference lies somewhere between minus 17 and 65. In other words, the confidence interval includes 0. So if you look up here, the t-test indicates that the p-value is larger than 0.05. In other words, the t-test says there is no difference. And in fact, here, our confidence interval gives you the same result because it's telling you that the difference between the weights includes, the confidence interval for the difference between the weights includes the value 0. If it didn't include the value 0, then we could say they are different, all right? We know that the body weights of males and females are not different in this sample of flying squirrels. Is that true generally across flying squirrels? And the answer is yes. Even if you had an infinitely large sample and you looked at the body weights of these animals, and we know this from much larger data sets, the body weights of males are not different from the body weights of females. Their body proportions are different, but not their body weights. Okay, that's it for the confidence intervals and the t-tests.